Welcome back to P3. Today we are looking at solving modulus problems, Unit 2.7. So this is the last of kind of Unit 2, functions and graphs. And it's all about really combining what we've looked at in the last couple of videos, the last couple of parts of this unit. So let's look at a problem. So here's our first question. We've got f of x equals 4 minus 3 mod x plus 1. So state the range of f. So to do that, first we need this point, this turning point. And this is going to happen when my modulus, or inside my modulus, is equal to 0. Okay, and it makes sense that that would be the case, because if you think this is negative, inside's always positive. Positive multiplied by negative 3 is always going to be negative. So any number inside here that isn't going to make this 0 will make this a smaller number, so it'll be either side here. Okay, so you can see that when x is negative 1, then this bracket is going to be 0. So I'd have 4 minus 0, so it's 4. So this actual point here is minus 1, 4. So this range, I can say that the range of f of x is going to be less than or equal to 4. Okay, part B. Give a reason why the inverse of f of x does not exist. Well, that's quite easy. We've got a many to one function. Many to one doesn't have an inverse. Inverse has to be 1 to 1. Okay, so if it didn't have a modulus sign in here, it would be 1 to 1 and it would have a inverse. This does not. Solve f of x is greater than 1. So for this, you want to kind of draw your line y equals 1. So that would look something like this. In this particular case, it actually goes through the y-intercept of the line here, but obviously not always would do that. And what we need to do is we need to basically work out these 2 points. In this case, this first one, if I call this A, this one's nice and easy, okay, because it is that intercept. But we'll still work it out as if we couldn't see that already. So if I look at A, this is the normal part of my graph. So this part of the graph is unaffected by the modulus sign. Okay, because you think it's a minus 3x type of graph, that's a minus 3x graph. Okay, so it's unaffected by the modulus sign. So if I'm looking to work out A, I'm just going to give myself a little bit more room. So at A, I'm going to write the graph exactly how it is, as if the modulus isn't there. And that's going to be equal to 1. And the 1 comes from this line, it's where the two lines meet. So this one at 1, and then this one obviously equaling it. And all I need to do now is solve this. So 4 minus 3x minus 3 equals 1. Take my 3x to the other side. I've got 4 minus 3 is 1, minus 1 is 0, so we can see x is equal to 0. And that is what we were expecting. Okay, let's move that up there. Now at B. So at B, this is now in the part of the line, part of the graph that is affected by the modulus. Okay, this is for negative values, this is affected by the modulus. So what I need to do is use the opposite sign when I'm dealing with this part. Okay, because this graph would be the same as this graph. Okay, so I would change the sign in front of my modulus for this one, make this equal to 1, and then solve. So we got 3x plus 7 equals 1, 3x equals minus 6, x equals minus 2. Okay, now on these then I also need to really give the y coordinate, but the y coordinate, as you know, is already here. Okay, so my coordinates at B are 0, 1, and my coordinates at A are 0, 1, my coordinates at B are negative 2, 1. And that's that question done. Okay, let's have a look at this one. F of x is equal to negative 10, negative x, and g of x equals 2 mod x plus b, and the minus 8 outside. So when they are equal, there is exactly one root. So I think what I'll do to start off with is a quick sketch of g of x. So g of x is going to have a minimum point at minus b minus 8. So it's going to be something like this. Okay, where this is going to be minus b minus 8. Okay, now this graph has a gradient you can see of 2, whereas this graph now is going to have a gradient of negative 1. So it's not going to be as steep a line, so maybe like this kind of steepness. This should work better. So the idea is that if it crosses anywhere up here, it's basically going to have 2 roots. Down here will be 0 roots. We want it when it crosses at this point. So this black line will be my f of x, and the red one is my g of x. Now, since I know what this coordinate is, this coordinate is minus b minus 8. So I want to substitute that into my f of x. So I'm substituting in that minus b. So you get minus 10 minus b, and I know that answer should be minus 8, the y value. So we got minus 10 plus b equals negative 8. So b is going to be 2. And that's it, solved. Okay, one thing you just need to be paying attention to and be aware of is the gradients. Okay, while these are just sketches, and the sketch is just there to help you, you know, this kind of gradient of 2 means that I've got this one and this one, they're going to be a steeper gradient than this one. Okay, so that's what's important, just so that if you can visualize it, it makes your life so much easier. Okay, I'm going to give you a few to try now. Okay, let's look at part A. Quick little sketch. Minus 3x plus 6, you know it's going to go through the 6. Minus 3x, so on this side of the graph it's going to look something like this. And then the modulus sign just means that what would have carried on up is now reflected. So it's going to be something like that. Okay, it's not reflected in the y-axis. It's just think of, you know, what would have happened as you went into the negative x's, would have carried on like that, and that's the reverse of what you're doing. Okay. Let's look at part B. shade the region of the graph that satisfies y is less than px. So this is going to be underneath the graph. I'm just going to re-sketch it again. Now, as I said, my graph looks something like this, but the difference is in this one I'm going to put dashed lines, and then the area under that will be this area. This is my shaded area here. Okay, and the dashed lines appear because this is a less than, not a less than or equal to. So that should be showing that this line should be dashed and not bold, because it cannot equal this line. Okay, and this is your y equals p of x line. I should also say that this is really going to be symmetrical, but that's not how you should approach it, is what I meant earlier. Okay, number 2, let's have a look. So we've got a 4x style graph. Looking at the minimum point, we got a minimum point at -6, 1. Okay, so that's what we need. And then we got quite a steep graph going up, and then this would be the other one, and this is at the point -6, 1, based on my minimum point. Another way you can think of this is, you know, what's happening to it. Think of your transformations. And what I mean by that is, I'll just give you a little bit. So, you know, if you imagined you were drawing, let's use it f of x rather than y, just x, then that is a graph like this. Now, if I mod that x, yeah, then this part of the line goes up like this. Now I think about what else I'm going to do to it. So if I, for example, changed into now f of mod x plus 6 plus 1, that's going to move this graph here. It's going to move it 6 to the left, 1 up. So instead it's going to end up like this. Okay, then when I look at the 4 in front of it, that is going to increase the y values, but it doesn't change the +1 because that's separate. So it's then going to be a steeper version of this, and that's where your kind of graph goes from. So it's, if you're having a little bit of trouble like drawing these or seeing what they look like, start off from the more kind of basic thinking graph, just a standard, like in this case x graph, y equals x, and build it up from there, you know. So it's just, and this one is a mod of x graph, and then you've got a transformation, and that might help you, you know, draw them if you're a little bit unsure. Okay. Okay, part B, state the range. This should be quite straightforward now. You can see from the graph that it is going to be greater than or equal to 1. Okay, nothing below. This is our minimum point, nothing below it. And then part C, when f of x equals -1/2 x plus 1. Okay, so I am going to have to make these equal, and I could just solve it purely algebraically first, check 2 answers and see which one works, or I can do a little sketch of the -1/2 x plus 1 and see where that is. So since this is minimum's already at -6, 1, then I know that this new graph, the -1/2 x plus 1, is going to hit in line with that -1/2 gradient of -1/2, so it's quite a shallow gradient compared to my gradient of my original graph here. So it's going to be something like this. So you can see here I've got 2 points of intersection. So I've got 2 answers here. So I've got an answer B, which will be in the original form of the graph, unaffected by the modulus sign, and the answer, the coordinates are A, which will be the one that is affected by the modulus sign. So looking at that then, if I want to find out where A is, I should be using minus in front of my modulus sign here. And so it should be a -1/2. And then expanding and simplifying. So -4x minus 24 plus 1. So add my 4x, so this is going to be 7 over 2x. Take away 1 is -24. And then I want to times by 2 divided by 7. So that's -48 divided by 7. So that's one answer there. So I just had to make some room there. And then let's look at finding coordinate B. So this one is where the modulus sign doesn't affect the graph. And then we have it, so 4x plus 24 plus 1 half x plus 1. So add that, so I'm going to get 9 over 2 x equals -24. So this is going to give me -48 over 9. I can divide both of these by 3. So -16 over 3, and there is my second coordinate. And I can substitute these in to check. Now, the reason I did that little extra bit on the sketch is so that I could see whether I needed 2 answers or 1 answer, because sometimes it might only hit this line in one place, and sometimes you might get 2 answers but only one of them's correct. So if you don't do the sketch and you get 2 answers, you should always substitute the answers back in to the original graph, including the modulus sign, to make sure it works. Okay, so if you don't do a sketch and you just do this algebraically, substitute back in, because sometimes you might get 2 answers but only one of them is actually viable. Okay. Okay, again on this one now I'm going to start off with a sketch. Personally I will always try and do a sketch with a lot of these just to see what's going on. I know sometimes with time pressures in exams you don't always like to do it when you don't need to, but I find them useful, and I think that if you can visualize a sketch, it does make your life a little bit easier sometimes. So turning point here will be 4 cross 6 up, so let's put it there, and we've got positive 3x, so we're going up this way and then this way off there. Okay, you can see if you put x equals 0 in, the -4 becomes a +4, 3 4s are 12, plus 6 18, so it should hit the y-axis +18. So that is a good indicator there. Now the f of x is a -2x, so it's something like that. And then think about it, so it's not as steep as these. We want no roots. Okay, no real roots. That actually means it won't hit, just misses. So what we want to do is find out what value of k it is when it hits this point, and then we can work out then everything below that then will be what we need as our answer. So where these will hit, okay, means that this minimum point here, which we know is 4, 6, we're going to assume that that is in our g of x graph. Sorry, I mean f of x graph there. So let's have a f of x equals minus 2x plus k. Substituting in that 4, 6 means, so I'm looking at f of 4, so minus 2 lots of 4 plus k, and that should equal 6. Negative 8 plus k equals 6. K equals 14. So that's quite important. So at this point here, this will be when these graphs have exactly one root. Anything then greater than 14 would have 2 roots. Anything less than 14 would have no roots. So value of k is actually less than 14. So that's our final answer there. Okay, so we're assuming one root up here. Okay, that's what we were doing there. Once we got that answer here, then we knew that less than that would be no roots, and like I said, greater than that would be 2 roots. So depending on the question, you can go either way there. But a lot of these questions where there's no roots, one root, two distinct roots, often you have to find that turning point first and use it, and then from there it's just a simple bit of logic. Okay, nice easy exam question here. State the range of g. Well, if I'm looking at that point there, sorry, I'll do it in red. Look at this point here, the turning point, this minimum point. We know that the y coordinate is -7 because it's up here in the graph. So very, very simple. The range of this g of x is greater than or equal to -7. Give a reason why the inverse of g doesn't exist. Well, it's a many to one function. Okay, doesn't have an inverse. It has to be a one-to-one function. So I won't write that down, but it's a many to one function is what you want to say. Only a one-to-one function has an inverse. Solve for g is less than 6. So for that you want to think, right, where is g equals 6? Well, I'll do this one in black. It will be a line across here. So we're going to have 2 possible answers, and obviously then we want less than 6, but I need to find these key points first. Okay, so they're often called critical values. So A and B would be the critical values in this case. Oh, sorry, I just noticed this should be it was a -6, wasn't it? Not a 6. Right, so it's just very straightforward. 2/3 x minus 1 minus 7 equals -6. 2/3 x minus 1 minus 7 equals -6. And this second one will be a negative. So just remember, when you're getting rid of your modulus signs, 1 positive, 1 negative, if you need to solve for 2 points, which we do in this case. So this first one here should give me b. So 2/3 x minus 1. Just going to move that over there out of the way. Equals, add the 7, so that's going to be 1. So let's multiply by 3. Let's expand the brackets. So we get 2x equals 5, x equals 5 over 2. That's my first answer. Let's do very much the same thing here. Multiply by 3, and this time minus 2x plus 2 equals 3. So 2x equals minus 1. So x is minus 1/2. Now I've got my 2 critical points. comes for the important bit. I want g is less than minus 6, which should really be g of x, but it doesn't matter. Less than minus 6, so it's below this line. So it's below this line when, now this is my minus a half, and b is my 5/2. So it's below the line, greater than minus a half, but less than 5/2. So my answer to this one would be minus a half. Sorry, x is between minus a half and 5/2. Just going to make a little bit of room for the final part. That's better. So state the range of values of k for which the equation has no solutions. So this one is quite straightforward, I think. The gradient you can see here is the same gradient as up there. Okay, so it's going to have exactly the same gradient. Okay, fitting over there. So you're thinking, right, it's where then it's going to hit my axes here. So you could just look to extend this line down. Okay, so we know the point here. This turning point is going to lie on both lines. So that's 1, 7. So we substitute that coordinate in. So g of 1. So 2/3 of 1 plus k equals, I'm sorry, it's -7. So k, taking away 2/3, -23/3. We obviously want no solutions, so we want when k is less than -23/3, and there we have it. Okay, question 5. So we know, looking at f of x here, a minus 2 brackets x plus 3. We know the coordinate 0, 4 lies on this line, so f of 0 must equal 4. So a minus 6 equals 4, so a equals 10. Okay, so very straightforward for the first one. So now our new graph or new function looks like f of x is 10 minus 2x plus 3. So immediately now we can find the coordinates of r. R is that turning point. So r should be the coordinate when x is -3, and y would then be 10. Nice and easy. Now to find s, we need that when quite clearly y is equal to 0, and it's this part of the graph I want. So this part of the graph is a -2x. So you can see -2x is when this modulus sign does not affect my graph. So when 10 minus 2 mod x plus 3 equals 0, but I get rid of the modulus signs, as I was saying, and it's the bit where they are not affecting my graph. So I keep it as it is in terms of the signs. So 10 equals, I'm gonna take this across the other side and change and expand it as well. So 2x plus 6, 2x equals 4, x equals 2. So my coordinates for s is 2, 0. Okay, let's just move that over a bit, give myself a little bit more room here. I'll just change to black. So f of x equals 1/3 x x plus 6, so gradient of a third hitting the 6, it's got to be above this 4, below the 10, which is r, and it's a shallow gradient, so something like this. So I've got 2 points, call them A and B. Dead easy. You can see here A is when I'm going to have to change the sign in front of my modulus when I turn it to brackets, and B as it stands. So I'm actually just going to very quickly rub this out because I don't have a lot of room. Okay, so as I was saying, let's go 10 minus 2 brackets x plus 3 equals 1/3 x plus 6, and 10 plus 2 brackets x plus 3 equals 1/3 x plus 6. Just need to solve both of these now. So 10 minus 2x minus 6. 4 minus 2x plus 6. So 7 over 3x, take away the 6. So x is minus 6 over 7. Okay, and that should be my value of b. So 10 plus 2x plus 6, x plus 6. I can cancel these, take 6 away from both sides. 2 take away a third is 5/3 x minus 10, taking that to the other side. Divided by 5 I get minus 2 times in by 3 minus 6. There's my 2 x values. But obviously I need the... Oh no, that's all I need to just solve it for x. Thought I needed the full coordinates then. So that's it. Final question. So state the range of p. Well, we know this coordinate is minus 3, 7 from our graph. So our range has got to be p of x is less than or equal to 7. Solve p of x 3/5 x plus 2. So that means I've got some sort of graph that looks something like this. Okay, it might be a little bit lower than this or a little bit higher, but I'm going to get 2 answers, okay, which is the important bit to know. So I've got minus 4 brackets x plus 3 plus 7 equals 3/5 x plus 2. To solve this one first, minus 4x minus 12 plus 7 equals 3/5 x plus 2. So minus 12 plus 7 minus 2, looking at minus 7. Take the 4x to the other side. 23 over 5x. So x is 35. Sorry, it's negative 35 over 23, just for that rearranging. Now part B, I'll just change the colour pen because I'm going to write next to it. So this time instead of minus 4, it's going to be plus 4 x plus 3 plus 7 equals 3/5 x plus 2. So expanding, we got 4x plus 12 plus 7, 3/5 x plus 2. 12 plus 7, take away 2 is going to give me 17. So that's negative 17, that's a 4, take away 3/5, 17 over 5x, x equals minus 5. Nice and easy there with the 17s. And then final question, let's use green. So p of x equals k is two distinct groups. So we're looking at y equals k. This is just like y equals 4, y equals 5. We're really looking at here y equals 7, aren't we? You know, that y equals 7 there. That would be one root. Below that would be two distinct roots. So k less than 7. Didn't even need to do any working out there for part C, just a bit of observation. So you know, it's a straight line, y equals 7, that would be one root, anything below it will have two roots. Thanks for watching. This is the last part of Unit 2. So next time now I'll go on to Unit 3 and trigonometric functions. If you found this useful, please subscribe, like, and send me your comments on what you think, any things I can improve, anything you want to see in particular, let me know.